So good afternoon everyone from the AEEE team. On behalf of Alliance for an Energy Efficient Economy, popularly known as AEEE, I am pleased to welcome all of you to this webinar. Thank you for joining. And before we begin, I would like to give a brief overview about this ION Zero webinar series that we have conceptualized and rolled out this year. This was prepared, this was presented in discussion with our members, with our stakeholders, and rolled out as a knowledge series. Presentations in the webinar will be based on these four broad thematic areas that you see on your screen. Today is the second episode of this webinar series, and we plan to hold at least one such webinar every month. Before we go any further, let me introduce myself and my colleagues from AEEE. So my name is Ritubroto Sen. You can address me as RBS Sen. I'm working as a lead partnerships at AEEE. I'm joined by my colleague online, whom you just saw speaking some time back, Mr. Pramod Kumar Singh, Senior Director, Research and Programs. In front of me, I have my colleagues from the cold chain team, Amer and Kushbu. If you could give a wave, that would let people know who is who. And on my right-hand side, I have Bhairav Sharma, Deputy Manager, Membership and Training from AEEE. I'll just take two slides to give you an overview about the organization. Many of you are already familiar with us. For those who are not, we are an industry-led premier research organization that was set up in 2008. Currently, we are headquartered in New Delhi, and all of us are taking this call from our Delhi office in Lajpat Nagar. The slide on your screen, I will not read it out, but it gives you an overview about our organization in terms of its vision, mission, and the organization goals for this decade. The RISE is more of an internal ethos and culture that we follow at AEEE. AEEE supports policy implementation and enables the energy efficiency market with a not-for-profit motive. We contribute towards India's goals on energy security, clean energy, and climate change by collaborating and working closely with the government and industry. As you can see at the bottom of your screen, we have 84 member organizations. They are the ones who make us unique in this space. They are closely involved in our projects and the programs that AEEE works on. In fact, the two esteemed presenters that we have today represent two of our member organizations. Primarily, the 5 verticals that AEEE works on, this is what you can see on your screen currently, starting from buildings, cooling, sustainable cooling, cold chain, smart and resilient power and mobility, global and local action, which represents our work at the national and the subnational, and also beyond the borders, work with government entities. And finally, decarbonization catalyst, which is cross-cutting and kind of a supporting vertical for the other 4. Today's, as you can see, one of the focus areas of AEEE is sustainable cold chain, and today's webinar focuses on innovative products and technology solutions for this sector. Before I bring in our presenters, I would request Pramod to please set the context for today's webinar.
Yeah, thank you. Thank you, RBS. And once again, I thank everyone for joining today's webinar. I trust everyone is doing okay. I want to take a moment to acknowledge the uncertainty that many of us might be feeling, given what's happening in the region for past couple of days. We are together on this. So regarding the topic of today's webinar, which is related to innovative products and technology solutions for sustainable cold chain, let me begin by underlining a simple but critical truth. Our food systems cannot be sustainable without cold chains. Cold chain is not just an infrastructure priority, it's a food security and a climate imperative. Now, why is it so? Let me try and unpack that for our participants. India is a paradoxical story of abundance, losses, and shortages when it comes to the fruits, vegetables, and overall agriculture. It poses serious social, economic, and climate challenges. On one hand, we are the second largest producer of fruits and vegetables globally, close to 350 million metric ton every year. Agriculture contributes about 18% to our country's GDP. It's the biggest employer. Almost 50% of our total workforce is engaged in agriculture. That's one part. But the other part, when we look at on every year, ballpark, we are losing about 10% of our fruits and vegetables produce um, because of inadequate post-harvest management. When we talk about the country priority, agriculture income growth is central to our poverty reduction goals. And inadequate cold chain is limiting that agriculture income. Inadequate cold chain is also resulting in food losses. So the problems of food loss are not, unique, and it's only with respect to the loss in value of produce. It also has bearing on our energy and climate. Food loss leads to emissions, mostly methane emissions, which are very potent greenhouse gases. Emissions cause climate change, which results in rise in temperature, and rise in temperature again aggravates food loss. Solution is cool chain. Cold chain requires cooling, and cooling requires energy. In order to power cold chain, if you are providing energy, then again it leads to emission. If we look at India today, almost 70 to 75% of our electricity requirement is coming from coal. So this is like a VCS circle where food loss, emissions, energy consumption, they are all linked. Five, almost 6 years back, India developed the India Cooling Action Plan, and as part of that action plan, the assessment was that if we look at cold chain, it's going to result in almost tenfold energy requirement between 2017-18 and 2037-38. So that underlined the need to have the new cold chain infrastructure developed in a manner which is energy efficient, which incorporates cleaner technologies, low GWP refrigerants, and also if there is a way to power these solutions using on-site renewable. Unless we bring uh, renewable generation and energy efficiency into our cold chain, the increased use, as I was mentioning earlier, will drive up our energy usage and it will drive up our CO2 emission. So it's very important that the cold chain of future uh, incorporates the highest level of energy efficiency and renewable energy, because that is what is going to help us meet our multi-dimensional goals of food security, nutritional security, income security, energy and climate security. At AEEE, we are working, our work on cold chain is addressing these two national imperatives, how farmers' income get doubled and how the objectives of India Cooling Action Plan are met. So our theory of change is very simple. We think that if stakeholders can be made aware, if they are capacitated, if they are resourced, if they are incentivized, and if they are well networked, then we'll be able to achieve our goals. And this is what we are doing day in and day out as part of our cold chain work. We are working on policy, we are working on project development, we are enabling finance, we are addressing the capacity issues and awareness issues. Today's webinar is a step in that direction. The two presenters that we have today, they will talk about how in their work they are using renewable powered cold chain solutions and how they are incorporating energy efficient technologies. Finally, I would like to say that cold chains are not just about cold storage. It's about how we are preserving value, how we are bringing equity in our society, and how we are addressing climate sustainability. So with that, I wish everyone a very productive session today and look forward to the insights that emerge from today's discussion. Thank you, and back to you, RBS. RBS, you are on mute.
Okay. Thank you, Pramod. That sets the context beautifully for today. So I would now request the presenters. We have two esteemed speakers, presenters today, and our first speaker, Alok Nikhade from Ecozen. Alok, as you can see on your screen, his topic and his brief, designation. But Alok is a lot more than what you see on your screen. So Alok, if I can request you to take a minute just to speak about yourself, your organization, and about your topic, and all of this you have to package in under a minute.
Sure. Thank you very much, AEEE, for hosting this exciting webinar. The series actually is exciting, so I'm happy to be a part here. I'm Alok Nikhade. I'm the AVP of Technology for R&D at Ecozen Solutions. I've been associated with Ecozen for the past 10 years, and we have been working on a wide range of technologies. My focus is on cooling solutions. So we talked about cold chain, so that is where the core tech development into bringing that to market, that is my role. Thank you very much.
Thank you, Alok. All the participants will be getting to hear from Alok very shortly. But before we allow him to do that, Vipin, our second speaker from Copeland, another AEEE member organization. Vipin, if you could take a minute about yourself, your organization, and the topic that you will be speaking about today.
Yeah, sure. Thanks, Ritu. Hello, everybody. I'm Vipin Vargat. I represent Copeland Refrigeration Solution as a product marketing manager. So Copeland basically is the world technology provider into air conditioning, refrigeration, and residential cooling, heating, and all these HVACR applications. Basically, our organization aim is to always make sure that we bring in sustainable solutions by day by day developing the technology and using the sustainable means like low GWP refrigerants, A2L refrigerants. So this is our organization into, and actually AEEE has brought this forum, which is ION Zero. I am really grateful to be part of this, and I hope that in today's session I could add value to this series of webinar. Thank you so much.
Thank you, Alok. Thank you, Vipin. So with this, the most important people in this webinar, the participants. So we would like to keep this very engaging and interactive. So I would strongly encourage all of you to put your questions during the presentation, whatever comes up in your mind, to put it in the chat box. We'll try to club questions and take it all up at the end of each presentation. So with that, I would request Alok from Ecozen to please share his screen and begin his presentation. Alok, you have 20 minutes, and at the 15th minute, we will ping you for the last 5 minutes wrap up. Over to you, Alok. We can see your screen, and hopefully you are on mute currently.
Yes. Good now?
Yes, all good. Over to you, Alok.
Thank you very much. I'm here from Ecozen Solutions. We have chosen the topic of innovative products and technology solutions for sustainable cold chain. And I, along with Vipin, will be talking about different aspects of addressing the problems of today's economy in India and the environment as well, the global environment as well. So if we talk about Ecozen is an Indian company established in 2010. And since then, we have been focusing on developing sustainable and smart technologies for cooling, for pumping, and rural motors. So we should understand what we are talking about. So this entire theme, ION Zero, it is actually talking about supporting the net zero goals. And what is net zero? So we are talking about a lot of emissions which are leading to global warming. So what can be the measures to reduce these impacts and build some counteractive measures to again abate that CO2 and other greenhouse gases, so that it can either be put into some alternate productive use, or we can reduce the emission altogether. Overall, our goal should be to reduce the rate of increase in the temperature. So we are talking about sea surface temperature, we are talking about uh, uh, terrain air temperatures. So this threshold should not exceed this 1.5 degrees Celsius. So that is what our goal is as a global community. We want to achieve this by 2050. So how is cold chain playing a role in this entire emissions and global warming? So when we talk about cold chain products, it contains everything originated from some cooling activity being done at farm to the last activity that we have in our domestic refrigerators. So all put together forms the cold chain, but there are certain subparts to it as well, which we are going to emphasize today. But if you look at these cold chain components, not all of these are going to have chimneys. They are not going to emit directly these flue gases, which are going to lead to some warming. But there is an indirect mechanism we should understand. So every cooling equipment is going to require some form of energy, and mostly it is driven by electricity. And when we are talking about the extent of cold chain requirements, and which we have not actually uh, able to make our presence across India, even now it is a big contribution to the total energy being consumed in the country. And if we see the rise in the demand, the terawatt hours is the energy requirement that is actually getting multiplied. So by the second decade, it will be 3 times what it was a couple of years back. And it will lead to 94 million tons of CO2 equivalent GHG emissions, and 150 plus million tons of GHG emissions. So this is a big, gigantic scale at which we have to take our measures. So I talked about cold chain being a very diverse and long chain of cooling activities. So out of that, the first mile solution will be a pack house. So we are harvesting commodities from the farm, and then they are getting aggregated, they are getting processed into some packaged format so that it can be sent to market. This particular sector had not seen cold chain for a very long time. So Ecosen came and tried to bring a solution there. We'll talk more on that, but if you look at numbers, so the number of pack houses from non-existent numbers, they are continuously rising now with the efforts being done by several initiatives, some by private companies, some by government initiatives. We'll talk about them as well. But if you see the trend, the amount of energy expenditure, if we go by the conventional route, it will amount to around 5 terawatt hours in these 2 decades. So that is a challenge. And the intervention that we require here are bringing in energy efficient technology infrastructure, bringing in those cooling equipment. We'll talk about the refrigerant that is in use to make the cooling possible, and the process entirely to make sure that the way the product was intended to, it continues to perform the same way across its lifetime. So the life cycle emissions should also be talked about. Similarly, cold storage is actually the word that people often get to hear about. And it is our apparent notion that cold storage is the way refrigeration works. So cold storage will also amount to close to the same number, like close to 4.8 terawatt hour of electricity demand will come for these cold storages. We are talking about bulk storages, we are talking about centralized storages. while when we are talking about pack houses, these are distributed small capacity installations. So both of them are going to be neck to neck in terms of energy demand and requirement of measures. If we talk about the kind of GHG emission impact, we are talking about up to 0.36 million tons of CO2 equivalent GHG emissions. That is huge. But when we talk about the sectors composing the perishables, these perishables are not seeing the light of day, like they are not seeing the plates of the consumers, and the consumers are not consuming the entirety of what was produced. So in this entire chain, it is anticipated that around 38% of all the harvest being produced in the country, we are losing them out. That is linked to loss of market linkage, maybe non-existent climate-proof solutions that can curtail the perils of high temperatures and inherent perishability of these commodities. If we try to link this to numbers, so these commodities are not going to consume electricity through their entire chain, but the way these decompose, they will start emitting greenhouse gas emissions by themselves. So the impact that you have to see is every 1,000 kilograms, so every ton of fruits and vegetables that is getting spoiled is going to generate 1.5 tons of CO2 equivalent greenhouse gases. And if we see the trend, and this is just India that we are referring to, from 2005 to 2018, the scale at which we are seeing the solid waste-based emissions, it is like a non-stop ladder. And if we continue the same way, in 2027, 2028 year, we will be having around 17.4 million tons of CO2 emissions just because of the waste. Another part which is actually not visible. So we talked about electricity being consumed. We see big infrastructures providing electricity. We see a lot of food waste that is visible to us. But when we talk about these cooling equipment, something that is invisible is the refrigerant. Now, refrigerant is a composition suitably selected which can provide right amount of cooling at the most efficient way. But these also are categorized to be generating global warming effect. And that is what is termed as GWP, global warming potential. To see the impact here as well, 1 kilogram of refrigerant would be the GWP equivalent of a CO2 emission. So when we refer to 404A, which is a popular refrigerant, it has 3,933 GWP, which means it is going to generate that much amount of kilograms of GHG emissions. So what can be done? So we are going to talk about what can be done to abate these kind of challenges in our industry. So I think for refrigerants, Vipin is going to talk more in detail, but I think my emphasis will be to be conscious while choosing the refrigerant, be conscious while producing a product which is going to support these cooling infrastructure. And maybe by a beautiful design, you can also minimize the requirement of refrigerant. So that is what my emphasis would be. But if you talk about all these three different segments, and if you want to bundle it up, the word that comes to my mind is clean cooling. We cannot go without cooling, but the mechanism with which we have been supporting our economy has not been so environmentally sensitive. So we have to come up with a sustainable solution which can continue to provide cooling, but with a lesser and drastically smaller impact on the environment. How to bring this cooling from conventional cooling to clean cooling? So we talked about a lot of electricity being consumed to produce this kind of cooling. So the source itself, the source of electricity It does not need to originate from the non-renewable sources. It can come from independent captive solar PV deployments as well. Now, the focus here should be about how we can run these machinery directly from our captive solar PV installations and not worry about how it is going to react. Is it going to be able to provide the right control of temperature even when the sunshine is not there? Then we have to talk about the refrigeration equipment. We talk about vapor compression refrigeration system. So how efficient can our system design be? How efficient can our compressor be? So that is where the role of companies like Copeland comes in. And then when we are talking about an erratic availability of electricity, even from solar PV, so there needs to be some mechanism of storing these particular potential. Now, we could definitely do this storage in the form of batteries, but what we would promote is that if we can store the cooling in the form of cooling itself, it will be the most efficient mechanism. So thermal energy storage is one such solution wherein you can store the cooling in the form of cooling itself, and you can retrieve the same cooling whenever the electricity supply is not available. Then the refrigerant component also comes into picture, where the system design, if we maybe use the traditional mechanisms, would end up consuming the older refrigerants. But when we talk about these HFO refrigerants, these are multi-fold lesser GHG emitting refrigerants. Then a good system design would actually take care of a smaller cooling requirement. So a combination of maximizing the volume, productivity, and the type of storage facility that you create by providing a good insulation, by providing good vapor barriers, you can actually offset the demand of cooling, which will have a direct impact on demand of electricity and perils of perishability. Then, so not just producing these kind of products, but also committing to quality. A good manufacturing would lead to a leak-tight refrigeration system, which would reduce the leakages of refrigerant into the environment. So that again, in turn, reduces the total demand for production of these refrigerants. So it's a very big impact. Then not just we are going to talk about providing the product at the location. We are trying to support locations which are farm locations, which are distant locations from regular infrastructure. So can we provide certain smart connect? Can we provide IoT to these products so that they are self-reliant in terms of automatic diagnostics, or automatic interaction with the user on how they want to utilize these kind of code rules. So Ecozen came up with this particular solution, which we term as EcoFrost Solar Cold Room. It is a smart IoT-enabled cold room where we focus on eliminating food waste, increasing the shelf life, increase the market reach of these particular produce, so they do not need to be wasted because there is no market for it, and at the end, increasing the farmer's income. To do so, we have been providing this solar PV powered solution where we can run the refrigeration system without having dependence on any batteries. So it increases the efficiency of power utilization. We are talking about a range of temperatures which are suitable for these perishable commodities, providing them moisture enabled good relative humidity so that there is no weight loss, and providing an assurance that the temperature will be maintained even when there is no power deficit. So that we are providing by coming up with this I-score, which we term for our thermal energy storage. So these solutions are available for a variety of sizes from 2 metric ton and to 30 metric ton storage capacities. Some of these variants are also portable. We can relocate from one farm to another. And when these are getting deployed in distant locations, these are getting connected by IoT. So you can monitor these devices how they are operating, and in case of long duration usages, you can also do diagnostics and analytical support remotely as well. If you talk about the comparison, how a conventional cold room would have fit in the similar demand. We are talking about a distributed cold chain infrastructure. So, for example, if you talk about a 5 metric ton kind of storage requirement, it would end up consuming 26 units of electricity. However, when we are dependent on solar PV as a power source, and we are able to maximize the utilization of that solar PV, you would actually end up saving all those 26 units of electricity. And also, when we are talking about conventional cold rooms, they would operate at some fixed temperatures, and those have to be based on the judgment of the users. So, on the contrary, EcoFrost Solar Cold Room would provide a PHM intelligence built in their mobile app, so that just click of a button on the mobile app would actually select the commodity and automatically configure the cold room for the kind of combinations of commodity that are stored. So not just one commodity, but if multiple commodities are also required to be stored, they can be managed with the same cold room. So no need of dedicated cold rooms for each type of commodity. And then we have talked about the cooling retention up to 30 hours. When we are talking about power source, which is kind of morning to evening, it is going to change the amount of energy that is produced by solar PV. So you have to have a refrigeration system which is capable of absorbing most of its available potential. So we provide a variable capacity refrigeration system. And obviously our focus is on sustainability. So we also take this to last mile, that the choice of refrigerant itself is also R448A, which is a low global warming potential refrigerant and zero impact on ozone depletion. It is also ASHRAE A1 class refrigerant, which means it is non-flammable, it is non-toxic as well. So can it support the kind of demands that are there? So yes, so it has inbuilt pull down capacity. So not just storage at a fixed temperature, you can pull the temperature down as well. So you can also ensure that the kind of quality that will be produced out of coming out of this will be long term. In terms of convenience, we have talked about it being connected to the online dashboards as well. So if you own multiple such cooling infrastructures, you can monitor them from a single location. So if you are coming up with a solution like this, how costly is it going to be? So that's a natural question. And how is it justified? So we definitely understand that there is a certain environmental aspect to it, but what is the economic impact as well? So that also we will try to understand via life cycle cost estimation. So if we compare these conventional cold rooms to solar cold room, the initial investment required is on the higher side. But if we talk about the uncertainty, so even if there is a 1 hour power cut in that particular location, it will lead to changes in temperature. So even if you put a diesel generator there, it will drastically increase the amount of monetary expense that is required to ensure the continuous service to these perishables. We can talk about the electricity that is going to be required. So these commercial tariffs are much more than our domestic tariffs. So the amount of money that you have to pay for continuously serving these infrastructure, it grows, it balloons up. So when we compare the life cycle cost per metric ton, the conventional cold rooms would end up costing you 6.6 lakh rupees per metric ton, but solar cold room would end up costing at 3.4 lakh rupees per metric ton. So even in the long term, it makes an economic sense, not just the environmental sense, to actually rely on renewable energy powered smart cold room solutions. Now, the technology may seem new, the implementation may not be so evident for everyone, but let me introduce to you that Ecozen has installed over 1,200 solar cold rooms across the globe. mostly in India. And so with that particular recognition, there are regulatory bodies who have actually started supporting in this particular front. So MIDH from horticulture, they have listed farm gate solar cold room as a potential option for all the pack houses in their 2015 guideline. Similarly, National Center for Cold Chain Development have released their engineering guidelines and minimum system standards, wherein they talk about solar standalone cold room, they talk about solar hybrid cold storages. So all of these are now getting recognized as the potential solutions. And when we talk about solar, Ministry of New and Renewable Energy have themselves released design specifications for and guidelines for how these solar cold rooms should be designed and what kind of capacities it can serve. So it is a very good platform starting from 2025 to actually now be confident that such an innovative solution can become a part of an Indian cold chain network. If you talk about the impact, so it is not just at the farm gate level, but we can talk about distributed infrastructure. So you can have a farmer working on it. You can also have a trader who is trading commodities, can store their day-to-day commodities, and also the retailers can also store commodities so that the last mile solution also is in place. If you talk about the impacts that Ecozen by themselves have seen, we have seen 15x savings at farmer level. So this is one particular case study talking about Ram Babu Singh. Another case study for Mr. Abhishek, who worked with pointed gourd parwal. So 80% reduction there. And then if we talk about conventional apples as well, so there is a 40% decrease in the losses that have to be borne without the cold chain. So the penetration of cold chain definitely is going to be a miraculous change in how the continuous supply of these essentials are in place, but also simultaneously bringing in climate resilience. If we talk about how the climate is getting impacted, I'll bring up this case study of a FPO, which is a community-owned cold room. If they were able to store their commodities, all the leftovers from day to day, and then bring that to only whichever can sell to the market, they were able to save 30% of their losses. Now, to do so, they would have actually required around 825 kind of units of electricity, but that would have generated 115 kilograms of GHG emissions. So by installing Ecozen's EcoFrost solar cold room, they have been able to abate that GHG emission. Also, a bigger chunk that the perishable commodity which would have spoiled would have generated around 22.5 metric ton of greenhouse gas emissions. So that is a big savings on the economy front as well as environment front. So it's not a new thing that Ecozen has been doing. It has we have been supporting this infrastructure from ground up. We have been supporting the farmers directly. We have been supporting different sectors of distribution and collection as well. Because of that global activity, we had been awarded this Global Leap Award in 2023, and then the REFCOLD Award, which is an Indian recognition in 2024 for synthetic refrigerant category, and this year 2025 we were awarded the CII Cold Chain Award. So I won't say that these awards are our recognition. Our recognition is the amount of impact that we are able to make as an organization in the climate, which is available for everyone, and we have to leave a good environment for our upcoming generations. So Ecozen as a whole, across its various products, we have been able to abate 2 million plus metric tons of GHG emissions. So that is a proud statement to say for me. And I would like to invite everyone who have joined this particular webinar to actually take up initiatives and be a part of this big change to build a smart and sustainable future. Thank you very much.
Thank you, Alok. You can stop sharing your screen. I got lost in your presentation and I didn't want to interrupt your flow, but by and large, you have been on time. Thanks for that. I'll now hand over to Amir he has some questions, I believe, for about 3 to 5 minutes for a brief Q&A with you based on your presentation. And over to Amir.
Thanks, Alok, for the insightful.
You are on mute. You are still on mute. Okay.
Yeah, I would request participants to drop their questions in the chat. In the meantime, I have a question for you, Alok. Would you like to give some insights into the features currently offered through remote monitoring and control to ensure energy efficiency, along with any potential features that can be integrated to enhance performance of the system?
Right. So I think one of the very good feature of our product is understanding how what kind of power sources are we working with. So the onboard smart control actually ensures that the preference is given to solar electricity generation, and it ensures that the cleaner energy is getting consumed. So automatically the requirement of grid-oriented electricity is minimized. And whenever there are alternate power sources available, then it would prefer the grid-connected electricity, and then lastly on any connected diesel generator. And it also has like automatic diesel generator cut in and cut out, so that one does not need to be present there. So you cannot be worrying that a lot of diesel is getting burnt just because it is connected to the product. Also, even when the grid is connected, it will ensure that the amount of electricity that is being consumed is minimized. So this IoT actually helps you monitor how much amount of electricity is being consumed from these alternate power sources, which are going to be costlier alternatives to solar. There is also a benefit that all of our products are connected with IoT, so we regularly provide these updates, which is known as firmware over the air. So most of the modern or updated energy efficient operation mechanisms are getting updated onto these devices, which are already in place. So everyone gets the same benefit.
Thanks, Alok. We have some questions from the participants. So one of the question is, do you use subcoolers or economizer to enhance the performance of your system?
Yeah, so definitely. So when we talk about the vapor compression refrigeration system, the conventional cycle would not have any vapor injection or liquid injection mechanism. When we are talking about a global rise in temperature, it also comes with a penalty on reducing efficiency of the compressor, which is the heart of a refrigeration system. So definitely, EcoSen solar cold rooms are powered with vapor injection enabled economizer benefited refrigeration systems.
In respect of time, we have a few more questions. We will take just one more question for you, Alok. Just a brief idea of like what is the current status of deployment in Indian market, and if you can just elaborate a bit on thermal energy storage. Yeah, participants would like to know about it.
When we talk about deployments, we have done close to 1,100 deployments in India, in the country. And there are, I think, up to 100 deployments beyond India as well. And regarding the thermal energy storage, I can understand the kind of curiosity, but it is much close to what you would see in your day-to-day solutions as well. So when you have a beverage, you would want it to stay chilled for a long duration. You would probably put in a cube of ice there. So it will maintain the same temperature for longer duration. You actually get to enjoy the beverage. That is because it stays at that particular temperature. Similarly, when we talk about liquid getting into solid phase, it stores a lot of cooling, and that cooling is known as thermal energy storage. And whenever you have maybe demand and uptick in demand that you want to provide more cooling, or you want to provide cooling when there is no active refrigeration being done by your refrigeration system, at that point of time, you can deposit the heat into these thermal energy storages. So it is much like the same beverage example, but in a sophisticated engineered product that it can provide the right amount of cooling, maintain the right amount of temperature for these cooling applications.
Sorry, Amir, sorry, Alok, for the sake of time, I'll interrupt and interject. What I would request, Alok, see what I can make out from the Q&A box. There's a lot of interest in what you presented. So if you can, I'm sure you can also see the Q&A box, and there is an option for the presenter as well to type their answers directly. Whatever you could not cover verbally, if you would like to share some links or very brief one-liners to those while I move on to Vipin, please feel free to do that so that the ones who are interested get their answers.
Yeah, I'll do that. Thank you.
Okay, thanks, Alok. Okay, now we move on to our second presenter, Vipin Vargat from Copeland. Vipin, over to you. Same set of instructions, 20 minutes, followed by 5 minutes of Q&A. Over to you. You can share your screen and I'll let you know once we can see.
Yeah. Okay, I'm sharing my screen. Hope it is visible now.
Can you go to full screen mode, please?
Is it full screen mode?
Not yet.
Oh, sorry. Hope it is now.
Yes, much better. Now it is full screen. Over to you, Vipin.
Thank you. Well, thanks, Alok, for covering this very interesting session. I mean, I'm really amazed to see what impact Ecozen's solar cold room can bring into this to make this world a better place. Right. So let's so as we have seen that the how solar cold room system can make a huge impact in the overall cold chain.
Slightly louder, Vipin. It would be better
Am I
if you're
not audible?
slightly louder.
Hello,
Yeah, much
is this better?
Yes.
All right. So let me just start with what Copeland is doing. Just pretty quick. So Copeland is uh, uh, into supporting the multiple sustainability linked megatrends, which are energy transition, refrigerant transition, and food pharmaceutical availability. In by 2050, the global demand for food and pharmaceutical and also for energy is going to go up by 50%. So as population is growing, then I think and it is more going to move in the urban areas. So there is a need to have organized cold chain infrastructure. Because of various lacks of the organized cold chain infrastructure in India, the data released by MOEFCC says that there were around 6.8 billion losses in 2023. And it was in various sectors, so fruit and vegetable, marine, seafood and poultry and meat and healthcare products. So how Coplan can support, ensuring that we come across and we prevent these losses is by offering sustainable solutions which can reduce the energy. Uh, the the solutions which uses ultra low GWP or low GWP refrigerants or even natural refrigerant to that extent. And as these solutions, they bring in the food which is 1,000 kilometers away and preserving it. So that helps to reduce the food and pharmaceutical losses. So that's a little bit about what exactly Copland is focusing on. So with that, I bring in here today is the one of the technologies that we are into, which is scroll compression technology, and this is so we are the one who has brought this technology in India, and then I think this session will be really interesting for you to understand the benefits of this technology in the cold chain system. So let me just take you through the basics of this. What is scroll compression first of all? So basically, scroll has two main parts, which are the scrolls which are actually compressing the refrigerant. So one of these scroll is fixed scroll, and then the second one is orbiting. So the red one is fixed scroll, and then the black one is it is orbited in the uh, centropic motion with the help of a shaft and motor. So if you see towards the right, the there are as this orbiting scroll moves around the fixed scroll, it creates various pockets. So I mean, the suction pocket is where if first low pressure refrigerant, vapor refrigerant gets into the compressor, and then there's an intermediate pocket which start the compression process, and then the third part of the stage of the compression process, where the high pressure pocket is created, and which is again further increases the pressure of the refrigerant. And the fourth is the discharge to the after the high pressure refrigerant is generated. So this is somewhat how the compression happens in scroll compressor. The scroll compressor consists of various important parts. So I'm just going to cover the important ones. The So first of all, the apart from these scrolls, which are shown here, I mean the side view, top view, axial view. The other parts are the HV wall, which are actually helping to shut down the device and improve the performance of the compressor at a high pressure. There is a BPM high efficiency motor which is going to drive the shaft, which ultimately is going to drive the scroll to compress the refrigerant. There are various safety the lubrication devices, which is positive displacement oil pump, which ensures the sections are lubricated at all speeds. Uh, there is a floating seal for axial compliance. So there's a axial compliance required for these scrolls to move freely. And of course, using there is a oil circulation control technology, as we have to ensure that the lubrication is properly done in the scroll. So to understand the so basically as far as the refrigeration is concerned, there are there has been a very popular technology in the market, which is reciprocating compression technology, right? So just wanted to give you a overview of how these two technologies stand versus each other. So the scroll, as I shown earlier, that it has two interleaving spiral shaped scrolls which are moving to compress the refrigerant. While in reciprocating compressors, the piston and crankshaft and cylinder mechanism, so just like an IC engine, it is working to compress the refrigerant to a higher pressure. So the scroll would have a circular motion, and then the reciprocating will have a piston which is moving up and down to compress the refrigerant. If you talk about the efficiency, the scroll compressors have relatively higher efficiency because of its higher volumetric efficiency, and then the reciprocating compressor has moderate level of efficiencies. The noise and vibration, because scroll has relatively less moving parts, so scroll compressors would produce relatively less noise and vibration, while reciprocating would have higher noise and vibration levels. Yeah, as the scroll would have, less moving parts, so of course, less moving parts meaning less wear and tear, and thus less maintenance as far as the scroll compressors are concerned. And while reciprocating compressors would require slightly, more or frequent maintenance. Uh, Nonetheless, from the durability and reliability point of view, of course, scroll would have a longer lifespan due to less wear and tear. However, the reciprocating compressors can handle, very, durable as because it is durable in nature. The reciprocating compressors can handle very aggressive environment as well. So the application per se, reciprocating compressors are more popular in light commercial and commercial refrigeration segments, while the scroll compressors are getting popularity in commercial and light industrial refrigeration applications. The scroll compressors, due to its design and the criticality in manufacturing the scroll compressors, it requires initially high initial cost, and reciprocating compressors would require lower initial cost. However, it is really important that while choosing the best technology for your refrigeration need, it is always necessary to assess the overall life cycle cost, so which will help you to decide which technology is better for your application need. So cost possibly for a small application wherein reciprocating compressor would have a initial cost, lower initial cost. So and in that application, maybe the cost would be a play a quite important role. So maybe reciprocating compression technology is better for your requirement. While light industrial refrigeration, wherein a cold room which has high level of variation in cooling load and all that, so I think in that case scroll could be a proper choice for such kind of refrigeration application. So this is how these two technologies are compared with each other. So the I want to take you through a couple of more the features of the scroll and which is accompanied with the variable speed technology. So basically, if you have a huge gap between supply and demand, and there are variations in voltage, current, and frequency of the driving power, which is actually driving your refrigeration system. So that's where variable speed technology plays a wider role. So basically, there's a variable speed drive which is controlled by the controller of the cold chain system, uh, and that is actually providing the signal for modulating the drive and ultimately driving the compressors to produce the refrigeration for the system. So in the actual operation, as you so in the actual operation as the fixed speed compressor, it will be operating at a various suction pressures because of its nature of operating at a fixed speed, uh, which ultimately going to cause a lot of increase on off cycles, and it will also not maintain the precise temperature of the compressor and as well as ultimately it is not going to maintain the right humidity in the cold room. While if it is variable speed, it will ensure that the suction pressure is maintained at a constant level, as it is going to modulate with the help of variable speed drive, and thus the compression efficiency will increase, and that's how the precise temperature will be maintained, and thus it will help you to maintain the humidity very well. Of course, as variable speed is actually driving the compressor, so the on-off cycles will go down, and thus the overall energy consumption will also come down. And as well as it will reduce the energy 15 to 20%, even 25% to some extent. This will help to reduce your scope or emissions of your facility. Of course, this with the help of the drive, the compressor can also be handle the various fluctuations in voltage and current, as this compressor can start the drive can start the compressor at a voltage of 64 as low as 64 volt, and can also start the compressor at a frequency as low as 30 hertz. So this is really help this helps really to not just improve the efficiency of the overall system, but also improve the reliability of the overall system by reducing the on-off cycle, and thus actually improve the shelf life of the overall refrigeration system and the compressor. Another technology that Copeland focuses on is the injection technology. So, well, what is injection technology? It is of two types: liquid injection and vapor injection. So fundamentally, if it is a liquid injection, so with the help of DTC valve, the liquid refrigerant from the refrigerant liquid line, that is after the condenser, is directly injected into the compressor. And in vapor injection, which has a little bit complex system to do this, wherein the same stream of liquid refrigerant is partly expanded, and with the help of plate heat exchanger, it is cooled down, and then it is injected into the compressor. So by actually, and it could be liquid injection or vapor injection. So it is basically acting as a equalizer of the refrigeration cycle. So it is enhancing the overall efficacy of the compressor compression, and thus providing savings of energy, and also enhancing the overall envelope of the compressor. And also, in addition to that, as this also enhances the envelope and bandwidth of compression, so it actually can also produce slightly higher capacity, so that way the size of the compressor can also be brought down. So basically, this is how there are some injection ports through the there's a injection port which is on the compressor. Just to show you, this is the injection port, and through this injection port, the liquid or vapor refrigerant is injected inside, and there are holes in the mid compression middle of the compression cycles, which actually helps to create two-stage compression inside. Okay, and because of this two-stage compression, the envelope of the compressor increases. It can deliver slightly higher capacity even at a higher ambient temperature. Of course, the energy efficiency improves, and as well as it also improves the life cycle the compressor. In addition to the vapor injection, I mean, of course, there are additional specifications which are really important. I mean, of course, without smart module, which is actually controlling this injection inside the compressor, without that, it is not possible to handle a vapor injection into the compressor. And in addition to that, additional functions such as mobile connect or oil protection would help to actually enhance the overall system reliability. Right. Let me go further. All right. So let's understand how the vapor injected scrolls stand against the conventional technology in terms of life cycle cost. So the vapor injected scrolls, the as for let's say for a 10 kilowatt of capacity for both the conventional and vapor injected scroll uh, has a so has been considered for, let's say, 6 units of uh, operation to overall 60 kilowatt of cooling capacity of a refrigeration system. EVA based scroll would consume about 7.37 kilowatt of power for 10 kilowatt of capacity, while conventional system will be close to uh, uh, 9.3 kilowatt of power input for similar capacity. So this itself saves around 20%, 20 to 21% of the energy, and it will have an OPEX savings of around 7,46,000 Indian rupees. And if we compare that with overall life cycle, you'll find that from year zero, there will be a total life cycle cost savings of around 22%, which is roughly about 30 lakhs, 30 million Indian rupees, and that compared to a paper injected scroll, which is close to 25 million Indian rupees. This capex can be recovered in less than 3 years. Of course, over the year you'll have around 20 to 24% of the OPEX savings that definitely can add value to your overall refrigeration system. So this is the kind of OPEX and savings or savings in terms of life cycle cost would bring in would brought in by the vapor injection, with a payback period of less than 3 years for based on the initial capex. Right. So these two technologies, which is variable speed and the EVI put together, that's what basically has been put into Ecozen's cold room solution. So how it is actually helping, as you know that the sun intensity will not be constant throughout the day, right? In the morning time, the intensity will be because of low solar radiation, the intensity will be lower, and it will be at its peak during the nude time, and then uh, during the the second half or towards the evening, it will again go down. So there will be a lot of variation in the power that will be generated to actually or refrigerate the goods that are stored inside the cold room. So the variable speed compressor, which can start at 67 volt and as a lowest power supply and a frequency which is as low as 30 hertz, actually adding a lot of value because of this variation in the power quality due to solar irradiance. So that's actually helping to enhance the overall solution that is been developed by Ecozen. Of course, by the use of variable speed and vapor injection technology, it is definitely adding a lot of value and saving, the saving the non-conventional energy which is produced by solar power by about 20%. The scrolls are which are compact in nature, so which are consuming less space than any conventional compressors. Of course, this solution it equips the lower GWP refrigerant, so thus it also helps to add on to the environment and making uh, uh, making it the overall solutions more sustainable in terms of having the green refrigerant in nature. Yeah, thus and as this solution is very unique in nature, so which is actually producing uh, the helping farmers to produce the goods and improving their overall income. Right. So a little bit I wanted to touch upon on the alternate refrigerants for sustainable refrigeration. So India is going to start their HFC phase down plan by 2029 to 30, and as India starts in the Group 2 of Article 5, as per the Kigali amendments that happened in 2021. So it is really important that the right refrigerants are brought in at the right time. So the so that we also uh, are able to smoothly handle this change of moving to the more eco-friendly refrigerant. So our focus is always been to provide better and more sustainable technologies to the market. So these are the refrigerant which Copeland as an organization is focusing on to develop more eco-friendly and more efficient solutions. Of course, compared to a most popular refrigerant as on today in India for refrigeration, which is R404A, these refrigerants they reduce the CO2 footprint by more than 95% because of its low GWP fresh potential. In addition to that, we also need to consider various aspects of this refrigerant, such as their familiar how they would stand in terms of compression capacity, how they would be how they'd be affecting the compression efficiency, and what would be the discharge temperature effect. So I think the refrigerant that I'm showing on the screen, R448A, 44455A, R4454C, 1234YF, are basically are of the really good compressor efficiency. I mean, they are better refrigerant than on 404A in terms of compressor efficiency, and it has comparable discharge temperature. And thus, and apart from that, this its green nature, and of course, reliability, which is not so bad. I think would be the choice of the future in order to uh, make the overall refrigeration, the refrigeration system more sustainable in nature. So, so with this, I think I would like to conclude this session on four important key areas, wherein so one the modulation in the technology, which is actually uh, uh, based on your supply and demand. I think use of variable or digital speed, which are actually modulating technologies in the refrigeration industry, would be the best choice to ensure that you achieve best life cycle uh, cost and best returns on your investment. Of course, the injection technology in refrigeration will help to add over to the benefit of what variable speed or digital modulation can bring in. So more better capacity, more efficiency, and okay, again, of course, improved reliability of the overall cold chain system. And definitely, it is not really possible without having an intelligent energy management system or control system for your refrigeration equipment. So definitely measuring that through a 24/7 hour monitoring kind of technology would really help to understand where your energy is going, and then using or optimizing the use of your energy based on the optimum requirement of your cold chain system. So that's really important. And of course, the last but not the least, the use of the greener refrigerant in the system would help to add on to your environment, and then making this world a better place for everybody. There are a couple of things which when choosing a cold chain system or refrigeration system for your cold room, there are only running costs which are considered as on today. However, there are other hidden costs such as maintenance costs, failures, refrigerant, and labor cost, which are not considered. And the initial cost doesn't play and doesn't give you the right uh, picture of the best technology that you should be using for your refrigeration needs. It is all this cost put together, which is the capex and opex. So always try to do the right estimation, right assessment for while you choose the best technology for your requirement. And I think this comparison will definitely help you to be more cost efficient and get best return on your investment by choosing the right solution. So yeah, with this, I think uh, I would like to request you to reach out to us if you have any questions. Of course, I'll be taking up some questions which are there in the chat. But apart from that, if uh, anything is there, please feel to reach out to me or reach out to the co-plan.
Thank you, Vipin. Can stop sharing your screen, and just like before, I'll hand over to Amir for the Q&A.
Thanks. Really insightful presentation. We have some questions. We have a question on are the R290 based scroll compressor with a minimum capacity of 0.5 TR available in Indian market? And following this question, there is one more question that if not, what is typical capacity of Copeland R290 based compressor available in India?
Okay, so basically, as far as the scroll, so we do have a range of reciprocating R290 compressors. As far as the capacities are concerned, I think we'll have to look at it and discuss it separately. We need to understand first of all your requirement of what is the actual application, and then what is the best solution possible for your application. And so that's why I think it's better that we go into detail of understanding your requirement. So could be the case that 0.5 TR could go down, or even could go up. So feel free to reach out to me if we can and take this offline. That's okay.
We will ask participant to please take this question offline. And there is one more question which one of the participant is asking for is like, do you have 1.5 TR reciprocating hermetical sealed R290 compressor or similar model? And I would also ask the participant to reach out for the quotation offline to Copland because she has asked for the quotation.
Yeah, please reach out to us, and we'll definitely be able to help you with the code.
It would be good to drop email ID. Yeah, drop an email ID in the chat, or maybe Vipin will get back to you.
Yes.
In any case, AEEE would act as a bridge. If at all you are not able to reach Copeland directly, we will act as a facilitator, connect you to Vipin. You have our email ID. Whosoever wants to get in touch with them, you can reach out to info@aeee.in. If not, to directly to Copeland. We will facilitate the connections.
Definitely.
So, with that, I think we are by and large, we have finished on time. We started a little late. But thank you once again, everyone, for joining. But before I let all of you go, I'm sure there have been a variety of participants in the webinar today, ranging from suppliers to might be from people from academics to people from even customers for that matter. So Amir, or if you have some takeaways, your top 3 takeaways as a sum up before we let our presenters and participants go.
Yeah. To summarize this presentation, it was really insightful, and we have some takeaways out of this presentation. Hopefully, everyone has learned something out of this presentation. So, first point is basically there are 3 primary sources of emission in the cold chain sector, which is electricity, food loss, and refrigerant. And these all emissions can be addressed through an energy efficient cold chain infrastructure, which was briefly highlighted by Ecozen and Copeland. The 2 panelists also highlighted the importance of collaboration amongst the industry players to bring in more sustainability in this high energy demand sector. The second takeaway is from is for the scroll type compressor. The scroll type compressor comes with various benefits in terms of design, operation, efficiency, maintenance, and durability. However, it comes with a higher cost, but it is important to consider the life cycle cost. And Vipin clearly highlighted that there is a saving of around 22%, and payback can be achieved in less than 3 years. Yeah, that's some of the takeaway from the presentation, and yeah.
Thank you, Amit. Thank you, participants. Thank you, Vipin and Alok, once again for joining and presenting and sharing your insights and your product solutions for our participants today. So I wish all of you a nice weekend, very good evening. With that, we would like to bring this webinar to a close. Thank you, everyone.